Hi guys, so for the past few weeks we've been climbing here at Gua Damai. In fact, I've been climbing here for more than 10 years, and we never really figured out anything about the caves. So today that's what we're gonna find out. We're gonna find out about the caves.
Okay, first of all, I would like to say thank you to everyone who is interested and attend this event, to this program. So today we will first do a sharing session first about information about Batu Cave, and then we will visit two caves nearby this area. Okay, so first let me give few informations about history of Batu Cave. So Batu Cave, actually for today, is it okay if I use multi-language mix, bahasa Melayu and English? Okay. Sure. So Batu Cave ni kalau ikut sejarahnya, ianya mula diterokai oleh oleh Mr. Sayers, iaitu Superintendent Polis yang
Mr.
Sayers, yeah.
S-Y.
Actually it's here.
Oh, okay. Thank you.
Okay. And Mr. Sayers actually Superintendent Police in Selangor, the first one, dan dia menjumpai kawasan ni apabila dia went for hunting party, dan dia terbau aroma guano. Guano is tahi kelawar. Okay, dan bila dia terbau, dan dia minta orang tempatan bawa dia dekat kawasan sini, and then they first cave yang dia discovered adalah Temple Cave. Okay, Temple Cave dulu nama dia adalah Gua Lambung, dan dia mula digunakan sebagai pusat untuk keagamaan pada tahun akhir tahun 18, dan Staircase mula dibina pada tahun 1940.
Oh, yang Tai Pusam tu lah.
Yes.
That one is Temple Cave lah.
Yes, the Temple Cave.
Tapi dulu itu Captain Sayers macam mana dia naik?
That one kena mendaki, rock climbing, the natural. Mendaki lah without ada stairs, okay. Kan. Okay. And then untuk sejarah penyelidikan pula, Mr. McClure telah menjalankan kajian di Dark Cave. Dark Cave adalah lokasinya berdekatan dengan Temple Cave. Dia berada di kalau naik tangga Batu Cave, dia berada di sebelah kiri bahagian tepi tangga dan berdekatan dengan Temple Cave.
Can you speak more English? My kids don't understand.
Oh, okay. Thank you. Okay, so in the Dark Cave, Mr. McClure do ecological study and recorded interesting species, and he has published his article in 1960. Okay, even though Batu Caves is well known internationally and locally, okay, but then highlight on its biodiversity is very less. Okay, and then there is no like major what we call studies conducted since Becklio and other European people doing study back then.
So there's a lot of biodiversity, but very little study on it. Okay.
Yes. So that's why we are here today. We are Malaysian Cave and Karst Conservancy, Persatuan Pemeliharaan Gua dan Karst Malaysia, and our team today, Dr. Ros Fatehah and also Dr. Rosli, will explain about the biodiversity and also geology at Batu Cave. So this Malaysian Cave and Karst Conservancy was established in 2015, and our first project is Batu Cave Scientific Expedition, Expedition Scientific Batu Cave. As you can see here, we have board of information about Batu Caves, about what we have conducted last year. The scientific expedition was held between January until December 2019. Okay, and we are part of organization that focusing more on cave research, cars, and also promoting sustainable use of cave and cars in Malaysia. So, in order to explain about cave at Batu Cave, I would like to invite Dr. Rosli to elaborate more. Okay.
Okay.
Hello everyone, thanks for coming. Okay, so I'm Dr. Rose from Geological Department. So in Faculty Science. So I'm basically a geomorphologist. So I call myself a geomorphologist. So a geologist that study landscape. So as you know, landscape, the preserved landscape that we see now, so mostly formed during the Quaternary, what we can see now. Okay, so it's Quaternary, which is 2.6 million years ago. Started from 2.6 million years ago. So first, I want to show you. I must show you this first. So those of you who already know geology, I'm sorry if this is already like a mundane thing to you. But I must show you this. Okay, this is so important. Even before I mentioned Quaternary just now. So this is a geological timescale. So you can find this on the net, everywhere on the net. So it depends on the development of the scale. So they keep on changing things based on the scientific finding. What I mean is, they may change the ages, may change the name, depending on the findings, okay, as they go along. Okay, they have some sort of organization that takes care of this geological timescale. So, okay, so we are here. Basically, we are here. Okay, recent. So what I mentioned earlier about Quaternary. Okay, the periods which starts about 2.6 million years ago. So this colorful, beautiful, simplified geological map is a bit old, I guess, because it only put 2.4, but it's okay. You can find the latest one if you want. And then the record here up to 4,000 million, which is what? 4 billion kan? Okay. So, okay. What we have here, the big rock in front of us, has been studied by geologists previously, and they actually figure out the age of about Upper Silurian, mid to Upper Silurian, which is about 430 million years. Okay, the rock, okay? But, like I mentioned earlier, you know, since the 400 million years ago, you have more deposition of rocks. So this 400 million years is called Silurian. Here, we are here. Okay, Silurian, 400 something. Okay, followed by Devonian, Permian, Triassic, Jurassic, Cretaceous. So Triassic to Cretaceous, Jurassic is the dinosaur ages over here. And we have a huge extinction, another one here, Permian, PT boundary. PT boundary is about what, 250 million years. So PT boundary is in Marapo. Okay, so it's already been discovered. The boundary was there, they found it. Okay, that actually marked another big extension.
How do you determine the boundary?
By looking at the rock, by studying the index fossil.
index fossil.
Yes.
That means there's certain marking
Yeah, certain
of the
marking,
fossil
yes.
that is known.
Yeah, no. So Permian, they have this certain index fossil which they call conodon. So they found it in Merapu. So on top of the conodon-bearing rock, they have Triassic. So they're very happy. We found the PT boundary. Okay, and then we go ahead and we have dinosaur here. Another big extinction. So dinosaur was wiped out. So we got no more. And then we have younger sediments, and we are here. Then we start to have ice ages, known ice ages from the Pleistocene, which is the first epoch of Quaternary. So 2.6 million years, we have started to have the evidences of alternating glacial, interglacial, okay, that finally brings us to the last glacial, which is about 20,000 years ago. And when the Earth start to get warmer and warmer, we have ice melt, we have rise in sea level, and we started to have the current climate. So from there, it's 11,000 years. The melting of the ice start to have our climate now, and then we start warming up. Kan? Now it's global warming. So that is another story. Okay, that is another story. Some people say it's part of the cycle. We are in the cycle, but if you look at the past record never show carbon dioxide, atmospheric carbon dioxide, to be more than 400 ppm. Okay, I digress now. I'm a bit out already, so I want to go quickly on Batu Caves. So as Dr. Atika mentioned earlier, okay, we've already done some work. So previous researcher has done some cave exploration. So they come up with about 20 caves. So this is the map. You can have a look at it later if you want in detail. So a lot of people, when we mention about Batu Cave, what do you think? The temple. But beyond that, it's another 20 caves, more actually, more 20.
Is there one particular cave called Batu Cave, or no?
No, I think the whole rock.
The whole rock is
The whole rock is called Batu Caves. Like over there, you have Batu Caves with an S, like plural.
the name is plural, right?
Right, but it's just right. Sometimes we forgot, right? Or maybe we Malaysianize it, become Batu Cave, right? Okay.
You can say the Malaysian Ayers Rock,
I'm going.
Yeah.
Kuala Lumpur's Ayers Rock.
Yeah. Okay. So basically, what we have here is Silurian rock that I mentioned earlier, and for this formation, it's called Kuala Lumpur limestone. Okay. So, okay, let me just mention about what is karst first. We are the society of karst. So, yeah. So karst is basically a landscape formed mostly by dissolution of carbonate rock. So carbonate rocks mostly is limestone and dolomite. Okay, so limestone is CaCO3. Dolomite has an additional Mg in the formula. So CaMgCO3. So in our here it's a mixture of magnesium. We have a mixture of limestone and dolomite. But basically, for a general term, we just use limestone. We will only know if it's dolomite by looking at the chemistry, looking at the rock analysis. Okay, so you know what karst is already. So it's all related to the limestone. So why you have this suddenly a huge chunk of rock in the middle of a flat plain? Okay, so this is actually a special kind of landscape evolution where you have dissolution along cracks or joints in the limestone, and the process in the tropical limestone especially the dissolution tends to go along cracks, and the rock can be dislodged from the mass. So dislodge, and what you have at the end is steep-sided towers. So at the moment in Selangor, of course, we know only 3 limestone towers, which are
Batu Caves.
Batu Caves, Anak Takun, and Bukit Takun.
Okay.
Only 3 in
Anak Takun and Bukit Takun.
Yes. And in Kinta Valley, you have quite a number, but still it's not.
Is Ketari what was it?
Yeah.
Police Ketari.
Yes, yes.
What about-
These have quite a number. Merapu also. So all the steep towers that you see is mostly basically karst.
What about the Clang Gates Ridge?
No, they're not karst.
Okay.
They look like karst, but they're not. They're actually quartz vein.
Okay.
It's all quartz, SiO2.
Okay.
Okay, so this is a cartoon diagram to show you, or I will show you later. We will show you later a few levels of a cave. Okay, so I will mention later to you as we as we go into the caves. Okay, so basically the cartoon here shows the current process that we have in the cave. We have rainwater, the water would go through cracks, okay, and may drips into caves. So that's why you have water drip in caves, okay. So with the drip, if the drip is saturated with calcite because of the dissolution, it may actually precipitate and again form new rock, which is secondary calcite deposit, which is stalagmite, stalactite, all those ornamental, nice cave deposits. Okay, so that's what we have in caves. I'll show you later. Okay, so let me just move on to a little bit on paleontology. Okay. So what is special to me and my colleagues about Batu Caves is my student found a very important orangutan. So we did the first report of discovery of orangutan in Peninsular Malaysia. So it's actually give us the idea of
Was this the one in Sistan?
yes. So it gives us the idea of the previous distribution of orangutan. So orangutan has been found in China, in Myanmar, in Vietnam, but they are all extinct except for
Sumatra.
yes. So that's why for us it's important that we know they actually roam here, they live here, but they are all gone now. So we found them in Batu Caves, and we found them in actually
Merapu.
4 caves in Batu Cave, and we found also in Lenggong. So I've been carrying this my precious luggage with me. So this is the real orangutan teeth that we found here. Okay, you can have a look later. And then besides that, we have a few others fauna that we found, and my PhD student Yasamin did a PhD on the whole discoveries. Okay, and one of the important thing as well is the age. So I mentioned earlier the age. Most of the materials in caves are in the quaternary ages. Okay, from 2.6 million years until present. So what we found, we have already dated in Batu Cave. The age of the orangutan is 33 to 66,000. Okay, and in Lenggong, it's more than 500. Lenggong material is so old, it's actually reached the limit of the method. So we are working on getting another method lah. Mungkin dia umur dia 700 ke 800. So we need to change our
Itu method tu carbon testing.
we do carbon dating. So I actually carbon dating.
Yeah.
Sorry, minta maaf. Uranium series.
Oh.
So our dating we use this is you know this already, maybe the half life of the
Okay.
isotope. So we use uranium 238 to thorium 230. So this is the material that we measured, and you do the calculation. So we got 33 to 66,000 ages for orangutan in Batu Caves. Okay, so I just show you this, just the method that we use, and we are doing a lot more.
What is the other method? What's the other method?
The other method, yes.
Lagi jauh.
Okay, lagi jauh, we will use uranium lead. Yeah, uranium lead will bring us to 700,000. So when we reach the limit of uranium thorium, we will move on to uranium lead. So some materials we are doing it now, but not from here. Belum lagi. We are doing materials from Nagamas and maybe like I mentioned, Legung as well. Because Legung has reached
the one the skeleton that taking from.
I'm not very sure if it's Sequin, but it's 1992. Nagamas was discovered in 1992. I think it's an earlier caver, but it's from MNS. So I don't know the name. In the report, they only mentioned caver, Malaysian Nature Society caver. They never mentioned the name.
Okay.
So I don't know who actually discovered the Nagamas.
Okay.
All right, that's all.
Okay, so now I will explain about plants that can be found at Batu Cave. So basically about 269 species of plants that can be found here based on a report by Dr. Rosli. Dr. Rosli is a plant limestone expert from FRIM. And there are about 51 plant species which is endemic in Malaysia, can be found here. It's like about 19% of plants that can be found here, and then on 4 species of plant that endemic only at Batu Cave, which means can only be found at Batu Cave. For example, this Epithema parvipagratum. Okay, and then other interesting plant here is you can see here Maxuratia. It's a fan palm plant, and it only can be found at summit of Batu Cave, and it's endemic at limestone hill around Selangor. And then even have heart-shaped fern. Okay, usually we found ferns like elongated leaf, but this one heart-shaped leaf. And then that's for plants. While and another one for plants, during Batu Cave scientific expeditions, researchers from University Malaya and FRIM have found out one interesting species. This species was recorded before in 1980s, but there is no any specimen, any preserved specimens. But they found this plant species at this Lembah Damai area. So this is new discovery for Batu Cave and also Peninsula Malaysia. While for animals, there are this is invertebrate. There are about more or less 250 invertebrates have been recorded, which including the laba-laba, the trapdoor spider. The trapdoor spider is very unique. It's endemic at Limestone Hill in Selangor. And this species is
The bahasa Malaysia pakai apa? Laba saja.
laba-laba. There is no like Malay name. So the scientific name is Lephiscus batuensis. And what's unique about this laba-laba? It have 3 segments at their body, which
Oh.
Same with dinosaur, same with
Insects.
spider that during dinosaur era. Okay, so
Sebab sekarang yang ada 2 segmen saja.
so this one is 3 segments, and some people also call this one living fossil hidup.
Right.
Sebab kita boleh dapat lagi di Batu Cave, but not cave.
And only in Selangor, not in Perak or anything.
No.
Okay.
Only in Selangor. And then there is also millipede, which if you can see, the shape is look like our spine. So this is also unique invertebrate that can be found here at Batu Cave. Other than that, we also have bats. There are about 10,000 up to 250,000 of bats that live in Batu Cave. So one of the important bats here is this bat species, Australia. The Malay name is Cheshire Gua. This bat species is nectarivorous bats. It's very, yes, the Malay name is Cheshire Gua. This
Quite cute.
nectarivorous bat is very important as durian pollinator. Research in Thailand have proved that this bat species is effective pollinator among bees, among birds for durian flower. It means if there is no this bat species, no durian. Okay? Yes. So exactly, actually, this bat species can fly up until 60 kilometer per night. So not necessarily we have durian plants here. We can have outside, but they can help pollinate the flowers. And even for mangrove plant as well, because it helps pollinate the mangrove plant called Soneratia species, or in Malay called berembang, which the Soneratia species have association dengan kelip-kelip, the firefly. Okay, you can usually find kelip-kelip at berembang plant. So this bat species will help pollinate the berembang flower. So it's very important, not just for durian, but also mangrove forest. So here we
are very far from mangrove forest.
Yes. Yeah, it can travel up to 60 kilometers. That's why the nearest mangrove area is at Clown. So research has
30 kilometers.
Yes. And 60 can up to tempat yang famous untuk kelip-kelip tu.
Kuala Selangor.
Kuala Selangor. Yeah. So here we have the bat species, so you can take a look.
Oh, okay.
The sample that we
Okay.
get from Batu Cave. And the other one is this one, insectivorous bats. Insectivorous bat eat mostly insects, and it can eat up to thousands of mosquitoes per hour in one night. So it's very important play role as insect suppressor. Dia boleh mengawal serangga penosa. Okay. So now I would to call upon Dr. Rosli to elaborate more about butterfly and Batu Cave.
Okay.
Hello everyone.
Hi.
So I'm doing the butterfly survey for Batu Caves. I found about 55 species, which is pretty good when you see that there's not much vegetation, or at least down here. I've also done butterfly survey in Kuala Selangor Nature Park. Can't remember exact number of species, but definitely less than here, maybe about 40 species like that. So even though it doesn't look like much, but it's pretty good. So important it's important to have some wild areas So shouldn't be cleared. Everything shouldn't be cleared. Otherwise, you know lah, macam di Lembah Damai ya. The last time saya pergi situ, sebelum gate tu semua dah clear. Di luar tu banyak saya dapat species. Paling banyak saya dapat species di situ. So saya dah tahu lah apa yang dah tahu what's happening outside the gate tu semua dah clear. Banyak rama-rama tu. Why is it important? Well, they are pollinators among others. Kalau there are no pollinators, there are no fruits, no new generation. So butterflies are very important, and other insects also that pollinate. The worry is kita sekarang makin hilang all these pollinators and insects in general. There is a district in China, Hongyuan district or something like that. They have used so much insecticide, dah tak ada pollinators, insect pollinators. So bila tak ada insect pollinators, what do they have to do? Orang yang melakukan kerja that have been done by these insects. So apa yang dia buat? Dia gunakan brush, go to a male flower, knock, dapatkan pollen dia, go to the female flower, knock, transfer the pollen. But those are only fruit trees, commercial yang ada commercial value. But di dunia ni bukan saja fruits that are important to us, but fruits or nectar, whatever, important to other creatures. So imagine if this problem spread all over the world, other parts of China, other parts of the world, then we are in big trouble. And every year we are losing 2.5% of our insects. 2.5% gone every year. So if you calculate, by the end of the century, no more insects. When no more insects, I can say definitely we are in deep trouble. There will be no life. No insects, no pollinators, and other services provided by butterflies and other insects. I can say we are gone also. We will be gone. No new fruit trees. We cannot survive.
Can we kill mosquitoes? Are mosquitoes pollinators?
So
This is my a big dilemma. I don't like mosquitoes. I don't think anybody likes mosquitoes. But only the females that feed on blood.
Yes.
The males they go for nectar.
Oh, okay. So they are pollinators, right?
And also I think the females they only take blood when they want to breed. Yeah.
Yes.
At other times, I'm sure they also go for nectar also.
Right.
So, but anyway, at least definitely the males go for nectar, and they pollinate.
Right.
And they also prey to birds and other dragonflies and other creatures.
Right.
So I'm sure every creature on Earth, they have a role to play in the ecosystem. And when you get rid something as numerous as mosquitoes, let's say we totally eradicate mosquitoes. Okay, maybe we feel it's good for us, but slowly nature will die.
Right.
Slowly nature will die.
Okay.
So they did an experiment in Germany to test what's the result of when there is no pollination. So they test 1, no pollination at all. 2, pollination by hand. And 3, pollination as usual by insects. So they found out that this is for apple trees in Germany. For no pollination at all, you still get some fruits. Not many, but you still get some fruits. And they are larger than normal. But there are no seeds. So no new apple trees. By hand, sama banyak apple, tapi kecil.
Oh.
And the best of course by insect pollination lah. And also selain daripada kecil dan atau besar, the nutrition value is different. Dia punya khasiat dia tak sama. So insects have been doing this for millions of years. So they know how to do it right lah kan. So again, so that's why very important that we have butterflies. And salah satu that I found is this very nice, very beautiful butterfly. It is called Julia butterfly. Julia butterfly. So bila saya jumpa sini, saya ingatkan, oh, this is a butterfly that is only found in limestone area kan. And then later when I went back, baca sikit, oh rupanya this is originated from Brazil dan Amerika sana. So what happened is, ini dilepaskan semasa festival, religious festival for good luck lah. In Phuket from a butterfly farm in Phuket, and then they spread down here. Now macam mana? So in order to survive here, two things are required. Satu, the anak tu, caterpillar tu, they need to feed on leaves that are available di Brazil sana. So rupanya ada di sini pokok tu. Why? Because orang introduce saya tak ingat nama pokok tu. People introduce those plants from Brazil and here. And then rama-rama ni pun they can feed on flowers yang diperkenalkan juga daripada Brazil. So that's how they can survive here. And saya nampak di Lembah Damai tu certain areas in Lembah Damai, this butterfly, Julia butterfly ni macam control the area lah. So dia macam dia dah jadi something di situ butterfly lain dah getting fewer and fewer. So there are two. The main problem, the main ecological problem in the world is pemusnahan habitat. We destroy our habitat, kita tebang hutan dan sebagainya. And the second biggest problem is the introduction of invasive species. Species dari luar datang sini. Selalunya bila makhluk lain datang dari tempat lain, dia tak pandai menyesuaikan diri kan. Tapi in certain cases like this Julia butterfly, because there are plants that the caterpillar can feed on, and the adult butterfly can have nectar from plants that are from there. So they become apart from just the food, for some other reason they became dominant. So they became daripada introduced species, they became invasive species. They kalahkan other local species. And when local species are gone, dia ada turutan dia, ada turutan akibat turutan dia. Mungkin burung makan rama-rama yang asal sini, tapi bila rama-rama tu dah tak ada, then burung tu pun dah I don't know what to feed on. So sequence of consequences lah terjadi. So invasive species is the second worst problem for our ecosystem. But I read somewhere that they are too common here to be eradicated. For example, there's a snakehead, ikan haruan, that have been introduced to North America. So they try to get rid. Sometimes they even poison the pond in order to get rid of the snakehead ikan haruan. But sometimes bigger than our normal haruan lah. Sometimes our normal haruan maybe that size, but the snakehead really besar lah. So maybe toman lah. Maybe it is actually the toman lah. Yeah. So this invasive species can be a real problem that people can do drastic things to get rid of them. So but I read somewhere, these are already too common in this region, not just Malaysia, that it's difficult to eradicate them. I checked my record. My first record actually not Batu Caves, but in Shah Alam botanical garden there.
Because too near to Sungai Buloh. I think.
Could be.
Sungai Buloh, you got a lot of, you bring in the imported flowers and the plants. And
Oh,
so probably,
yeah. Could
Oh, right.
be.
yeah, the nursery is there.
Okay, so on this topic, so it is dangerous when you buy exotic plants, exotic animals, and then you get tired of them. Then you get, especially animals, you get rid, you just throw them away. Yeah? You think you're being kind to them, you release in the stream, in the rivers, they might multiply, and then again they might displace, they might kill the local fish and whatnot. So yeah, dangerous to just release whatever that you don't like. Okay, I found, well, this is quite common. This is the smallest butterfly in Peninsular Malaysia. This one is common in the north, in Kedah, atas Kedah, and to the north. Tapi for some reason, I don't know why they like it here. Ada satu species called the smaller wood nymphs. Dia putih, putih hitam pattern. That I've never found in other lowland areas. Selalu saya jumpa di Bukit Fraser lah, di Awana sana kan. But for some reason here is quite common. Dia terbang relax ya. So dia two kinds of flight untuk rama-rama. Satu yang terbang macam pelang tribut tu ya. Relax ya, they don't care about anything ya.
Macam Raja Brook ah.
So Raja Brook is pretty relaxed.
Yeah.
And there's a reason for that. Yang terbang itu, these are tak beracun. So bila dia terbang tu susah sikit bagi for birds to catch. Yang relax tu itu beracun tu. Itu beracun.
Right.
So they don't care about anything. I'm just flying slowly ya. So yang saya kata smaller wood nymphs tu yang corak putih hitam tu, that's toxic. Atau not toxic, tapi dia copy, dia mimic a species that is toxic.
Right.
Macam pula ya. In many animals, they might resemble non-toxic, but they resemble toxic species. So they can, so other animals are afraid to eat them lah.
It's really interesting.
Yeah, adaptation lah. So I don't know what else to tell you. This is a real forest species. You don't find them flying outside here.
So in other words, if the children were to go and catch butterfly, we encourage them to catch the invasive species. Oh yes, it's already so brightly colored.
Yes, it's beautiful. You know the size. That's why butterfly farms they like this. Yeah. It seems like cruel to get rid of any animal. But it is a dangerous consequence. They can affect other, like this, it can affect other butterflies and affect the ecosystem in general.
So, but human, I think we should control that one even more. Human is the one that doing all this.
Okay, I don't want to go into that. I can tell you, in the ecosystem, you need to keep everything in balance. The main important thing is between predator and prey. If prey goes up, prey like yang makan rumput, then predator yang tigers and all that lah.
Sekarang is monyet dan babi hutan.
Iyalah. So if there are too many prey, they eat away the grass. Kalau kita pergi macam di Kuala Ganda sana, Bukit Rengit sana, there's a deer farm ya. They eat away everything, so botak all the ground because they don't have predators. So too many prey, rusa ke, babi hutan ke, they'll damage the ecosystem. So you need predator to eat them. So but we are the greatest predator, macam you kata. You see the human population going like that, and all the other animals going like that.
I got a quick,
Yeah, maybe,
I got a quick question. You said the invasive species is the second largest
Yes, second largest problem. Yeah.
problem, and the first one is human
habitat destruction. Yeah.
human activity. Then one of the nearby popular human activity here is rock climbing. Is rock climbing like something that's detrimental to like
Okay.
species?
Maybe Dr. Rose know better lah.
Okay.
But anyway, it may or may not be.
Right.
But just in case it's detrimental, so we allocate only certain areas,
limited,
Not,
yeah.
not so that people can't just go anywhere they like.
Right.
Even forests, you should follow the trail. Don't go off the trail.
Okay.
Okay. In case ada soalan ke?
Okay, thank you, Dr. Rosli.
Thank you.
So after this we will go to the cave. So we will feed more information as we go by. So before we go to the cave, I would like to introduce Cik Mustafa here, Damai Management Head. Okay, so Cik Mustafa is main operator for the rock climbing, as well as a few other activities here like caving, zip lining, jungle trekking. So this today's program is like collaboration with Malaysian Cave and Karst Conservancy and Glo Damai Extreme Park. So maybe Cik Mustafa would like to say something.
Okay.
Okay. Maybe later when we go to the cave, maybe Cik Mustafa want to introduce the area later. So in order to go to the cave, we need to drive. It's about 10 minutes journey. So Pak Mus nanti boleh lead ke road. So I think everyone can berkumpul and then kita akan start gerak in about 10 minutes. Okay?
Okay. Thank you.
So we can continue after we arrive to the cave.
Okay. Thanks.
This one, this is the nectar.
Yeah.
You call it cecadu. This bag, cecadu.
Tanya Atika.
Oh, okay.
Okay.
Okay, okay. Just a quick one before we move. This is very, very so rare. Okay.
It's a fossil?
So actually found in Batu Caves, in quarry rubble. So this is actually honeycomb. Yeah.
Fossilized?
Yes, fossilized honeycomb. So it is really, really rare. So precious. So actually, the sample, a bit of the sediment is in Nanyang Technological University now for the age determination.
Oh.
Yeah. So this is actually rare. If you Google, you don't find it. Nice.
Can I touch it?
Okay. I open this for you
like
if
a
you
rock,
want to
right?
have a look. So even the label, I bring the label with me just to show you. It has been sitting in our department for like more than 30 years. And then my colleague found it after Stoffer left. So Stoffer just passed away a few years ago. So my colleague said, Rose, why don't you do something on this thing? Because it says here it has been found in Batu Caves. So why not you work on this in detail, do CT scanning, look at the inside of the thing, and maybe you do some age determination so we know maybe old age B activities there. So I would have to work with an entomologist. Then maybe later. once we got-
How do you get it so polished?
that one is only cutting,
Oh, from the cutting itself.
and we polish.
So it became marble actually.
Yes, it's very nice.
Yeah.
This
Very
looks
nice.
like
But I'm a bit sad in terms of we have lost
like
a bit
wa-
of this
looks like water
material
jet.
due to cutting. So it's actually lost quite a bit.
Oh, lost quite a bit already during the cutting.
So I wish we already have a diamond saw machine so
This
that
was-
we can preserve.
This was 30 years ago they cut this.
Yes. This has been found in 1970. I was not even born.
Wow.
Yeah.
So
And
you're
then-
as young as
Yeah, so people retire and left, and then this has been
that's really old.
somewhere in storage for berapa tahun, 40 years. So when my colleague showed me this, he
That means
actually
UM
asked
dalam sana got a lot harta karun there lah.
banyak harta karun. So this is one of the things that is to me is so important. So important to us geologists. So I'm working on it. So we really hope to get a good age for this.
Okay.
Yeah. So, and then this is inilah orangutan.
Recent find, right?
Interested? Yeah.
Recent find, right? This one.
Yeah, this one a few years ago.
Yeah.
And then we already published in a Journal of Human Evolution. So the paper, the full article, you can find in the internet. So we already shared
Okay,
the full
thank you.
article in the internet if you're interested to know more about the orangutan. Okay. So I think.
So it turns out we are not going to check out the caves on this side. We're going to drive over to the other end of the rock. This rock that we call Batu Cave. What we normally call Batu Caves is actually a system of caves inside this rock. And we call the system of caves and the rock itself Batu Caves. But because of our Malaysian English, we kind of localized it and it became Batu Cave. Yeah.
The stripe is too loose.
The stripe is too loose. Okay, I'll adjust it for you. Okay. Okay, we're going here. We're going here. I have an interview in an hour. No, in 2 hours. I have to leave here in an hour. So we're at a site of Batu Caves that I don't think I have been here before, even though I've been to a few of the climbing walls here.
This looks like a good boulder.
Yeah,
You want me to tighten it?
yeah, that does look like a good boulder.
No, no
Okay.
tighten.
Yes, in a minute. So we are gonna be going into a cave, so we might not be able to take any videos because it might be too dark. But we'll see how we go.
Can we tighten now? There's one happening once I put it on.
Huh?
If you touch that, it will close so much of it.
Try and see.
Everyone turn to Lembah Damai.
Wait, no, not this one, like this
Yeah.
one.
So here two caves.
You're right.
Has recorded this place a nest for the fastest birds in the world, which is peregrine falcon.
Yeah.
Yes, peregrine falcon. You can previous research found out the nest is around here. There are two.
Migratory or what?
I didn't know much about it.
Resident.
Yeah, resident.
They based on the report, right?
Some are migratory, some are resident. If they have a nest here, then resident.
There are like two places here at Lembah Damai and another one nearby the YTL train station nearby the temple.
Nah, dia tak ramai.
And
There's
here at
a
Lembah
macam
Damai as
definition je lah.
well,
Kalau beranak sini, then it's resident.
I actually conduct a study on bats and we have recorded about 9 bat species. only at this area. At Batu Cave, there are about previous record 18, and from our research during Batu Cave scientific expedition, we found new 5 record. So it makes 23, and then at this area about 9 species. So this is some of the species that can be found here. It's also including this species, Rosetta's hazelpie.
Tu yang durian tadi
No, this one is different. Rosetta's hazelpie. This is the durian one. This one is we can call in Peninsular Malaysia. It only can be found at Batu Cave. So Batu Cave is really unique, interesting because it have interesting discovery.
Do you manage to catch the specimen or take photograph of the specimen?
We managed to take the live specimens and then take the photograph and then release back.
Oh, using the back net, the mist net. Is it?
Yeah, we use mist net, we use hub trap, high net, we use several techniques. Okay. So later in the cave you will see some species, and make sure don't point your light on the bats because bat is very sensitive. It will disturb them. So please be in group, quiet, and don't put your
next time just hit,
light
okay?
on the bats. Okay.
No need to ask me for permission.
So other than that,
If it's on my face, just
Okay, just a quick one. So you know, cave is what? Hole in rock, right? So the main process of cave formation is dissolution. So basically, in nature, rainwater combined with atmospheric carbon dioxide, and it produces a weak acid. But we are talking about thousands or maybe millions of years new process. So that's why, with the dissolution, you will finally have hole in rock. So the hole can be huge. Okay, so for example, the one in Molu. So this is the process. Okay, just a quick one, just a demo. Okay, so you have weak acid.
This is
weak
strong acid.
Strong, huh?
This is stronger acid.
Okay.
Just to show you. Yes, hydrochloric. Just to show you, this is a dissolution that happens thousands of years, and this is kata apa, the main
go in front.
reaction
Max, go in front. See.
for the
So she's using a strong acid
So
now
this is limestone?
this is
to dissolve the rock. You can see the limestone.
okay. So
She dropped
just
2
a
drops.
quick demonstration. So we always do this. We always bring this in our bag during field work just to make sure that we're dealing with the carbonate.
Limestone.
So limestone. So sometimes we're not very sure, so we just like tick, just to see, you know.
Limestone, and the other one is what was the
Quartz,
name of
is it?
no, the
Quartz or silica?
dolomite.
Dolomite.
Also-
that one is dolomite.
Also will be dissolved by
because
this.
of lesser calcite in dolomite, because it's already mixed with magnesium, so the dissolution rate can be a bit slower.
right.
Yeah. But you cannot really see sometimes.
Okay.
Okay. So this is a piece of breccia. Okay, breccia. So this is a porcupine tooth. So this is a piece of sediment just to show you how we found teeth in cave sediment. So we'll show you later in the cave.
Somebody mentioned that the porcupine move like the teeth into the cave, I think, if I remember correctly.
No, that was what Hassan said.
No? What was?
Something else.
What did he say? Oh, okay. Never mind.
It definitely wasn't what you said.
But may I ask, why is this is Batu Kapur, right?
Yeah,
Supposed
Batu
to be.
Kapur, yeah.
But why is it like shining and all that, like quartz like that?
Yeah, it's a calcitic limestone. It's you have huge crystals of calcite, clean calcite, very nice.
Okay.
But it looks like can be mistaken to quartz, right?
Yes.
So sometimes that's why we do the strength test, the hardness test. We do the acid test just
Right.
to see. Earlier, apa ni kata preliminary testing.
Preliminary
Even done
testing.
in the
Before-
field.
Ini really
Right.
compressed limestone lah. dia.
Yeah. And then sometimes it can also be marbleized or metamorphosed, a bit melted and recrystallized. So that's why you got a huge crystals.
Right.
So it's common in metamorphosed limestone.
Metamorphic rock.
Yeah, metamorphic. It's part of metamorphic. So if it's metamorphic, so we call it marble. But general term, we call it limestone.
Right.
Even in Kitab Liput, it's actually marble, but we call it limestone. We use
So marble is limestone lah.
yeah, it's originated from limestone that has been metamorphosed, has been
Okay.
heated by intrusion, granite intrusion, for example. So it can be slightly melted and recrystallized. Okay, so when it's recrystallized, you may not find fossils anymore.
All right.
So, for example, Silurian fossil no longer can be found in certain areas because the rock has been metamorphosed. Why?
Right.
During metamorphism, all the
Organic.
fossils destroyed.
Right.
So you only find something like this. Okay, so it's a long
Because
story,
bones
a lot of it.
bones are made of calcium as well. So because bones are made of calcium as well, so they can also be dissolved.
Can also be dissolved.
Right.
Yeah.
So I believe everyone excited to go to the cave now. So we go now.
Okay.
Bones are calcium plus.
So just follow those who have the light.
I forgot what it's called. We gotta look it up.
CO3, right?
Yeah. Bones are.
I'll be following your YouTube channel later.
Oh, okay. Thanks. You'll be the first visitor, I think.
First visit. Oh, you just started, is it?
Recently, yeah.
Recently.
Yeah. Not,
Slowly but surely.
oh, thank you.
Claustrophobic, is it?
There we go.
If you're claustrophobic, the only thing is to make yourself smaller. Not to stand up, but to really kneel down, then everything will look bigger.
You're going back up? Okay, see you, Shamila.
Yes, I'll find out outside.
If only they put in some lights. Not supposed to bring the light. She went out already.
You follow us lah. You follow us. You follow us lah. We'll be okay.
That's nice. Dia macam dia meleleh daripada air.
Can you see the glittery stuff?
You can see more inside the one air mengalir masih ada lagi di dalam.
Okay, everyone. Maybe you can like. That's it, right? Is it right?
Yeah.
Okay, fine. This is Ichibawa Cave, and inside this cave there are two species of bats here. First one is Hyposidorus
Whoever named this
nereus,
cave really
small one.
Ichibawa.
And then
MNS.
another one is
Mendes terrible.
I'm not sure whether if you pass by the entrance just now, you can see one individual of bat roosting at the ceiling. So that's the bat here, and my testicola. And now I would like to explain about cave adaptation. So as you inside the caves, it's dark, right? So few insects and usually animals that live in the cave, there's certain adaptations. For example, pale or white colors of body, and then elongated leg, for example, like this one. long-legged centipede, and then cave cricket. Okay, so this is another this is example for the whitish body of the spiny millipede, and then this is the snake, cave racer, and why it needs like longer appendage, longer leg, because it's important for them to sense, especially in the dark. Okay, so
You okay?
anything about fossil?
Okay. So as you came or you walk in just now, you actually can see on your left and right sediments. Okay. So what I'm talking about sediments, I always mention sediments. There are many types of sediments. So what you see as you walk in is actually sediment that has been brought in by the river flow. Okay. You cannot see river now, but it used to be river.
Yes, it was what
Yes,
was going.
it used to be river. So a lot of the orangutan, teeth, and also other fauna field were discovered in this kind of sediment. Okay, so we are not very sure of if they die here, if the animal die in the cave, but actually get reworked and deposited when the environment is calm, or maybe the teeth were brought in by the fluvial activity by the river and then got stranded here. So there are still something that we need to look into and discuss. Another thing about this is cave evolution, cave formation. So you walk along something like a narrow passages, right? And we came to a bigger chamber, and soon you will see another long narrow chamber. So when we go to another cave, you see big chamber. So this is all related to the formation of the cave, the evolution of the cave. All these narrow passages actually has followed certain direction. It doesn't happen randomly. So this direction is actually...
Your phone has no signal, so I can't help you with that at the moment.
Sorry about that. So the structure is actually follows a certain structural trend. So this is actually deformation trend that happens all over the rock. Even if you look at the Google image, you will see lineament. You can see something like a line if you look closely on the outcrop on the limestone hill. So over here, you can see it in the form of cave passages. So the water actually flows into these cracks and joints because the cracks and joints already provide the area of weakness. Peluang ataupun spaces for the water to first seep and start flow into and at the same time dissolve. Okay, at the same time dissolve the rock, and at the end you will have the passages and later chamber. So that's my point now, just to give you the idea of how the formation actually follows certain trends.
Cool.
Okay, that's all.
Okay, let's move further inside and we see around. If we lucky, we can see the invertebrate snakes.
Oh, okay.
Okay,
Insects.
so please stay in line.
By insects.
I think there are more insects and spiders as well. Can you see bats flying around?
Yeah, we're not supposed to shine our light at the bats.
Ustaz, tahu saya tak? Saya satu malam kita ganti. Ada kan? Ya, benar. Yeah, but 1997.
Oh, careful.
So I've been camping one night in cave and camping one night in the
Yeah, go on.
Oh, cave cricket. No, yeah, we saw some on the wall.
Oh, here, no, I got a picture for you.
Yeah, I saw. There are a lot on the wall.
When we went to Japan,
Same time pick up what it dissolved, which is calcite, one of the minerals that they forgot to pick up along the process. So the water can actually eventually be oversaturated with calcite. Kan dia dah tepu dengan calcite. So when it's oversaturated, what happens? In a good environment, in a good temperature, the water is precipitated, leaving behind the
Stalactite.
yes, the sediment, the crystal. So as you can see, the water drips. Betul tak?
Yes.
Okay, the water drip. Oh, sorry. So guys, you can see water drip. Very nice drip. Very slow drip. Okay, slow drip.
Yeah.
Okay. So as it drips, at the same time the water precipitates and form the what we call as cave formation. So everything that you see, the nice one, the shiny one on the floor, as Gopro is actually basically is the same process. Okay, but if you have a lot of water, for example, heavy rain, you may have kata apa? A higher drip, faster drip. So sometimes the water don't have enough time to make it saturated.
Right.
Okay, so now the water can be undersaturated and may actually dissolve.
Right.
So the water can actually deposit and dissolve, and dissolve. We can actually see the process when we cut, for example, a stalagmite. So we can see at the 3 rings, there must be some deposition, dissolution, and maybe a quiet time, hiatus, no more growing.
Right.
Along the growth of a stalagmite. That's why stalagmite is very important in paleoclimate studies.
Right.
So because the information of the atmosphere is stored in the water and transferred into the sediment or the calcite. Okay? But that is a long story. I'm not going to go into that. We don't have the time. Ada apa lagi?
Okay, can we do one activities first? Can we make a big circle first?
Let's form a big circle. Form a big circle. Siming, move over here. Careful.
So you remember just now I mentioned about cave adaptation. So we get to experience the darkness of the cave. So I think everyone to switch off the
Siming, let's turn off the...
count. 1, 2, 3. Switch off the light, please.
Everybody stop. There's a blue light there though.
The blue light is there.
So can you imagine how
Put your hand over it, yeah.
invertebrates walk inside the cave? With long legs.
Oh.
So actually that's also part of evolution process. That's why if you see invertebrate inside and outside the cave is different. Okay?
Max and Justin, are you okay?
Okay. So before we evolve to have a longer hand and longer legs like fish on our life.
So it's like a cricket, but the legs are very long.
Yeah. Cricket, this is shorter.
Yeah.
Cricket shorter.
So you use the long legs. Ooh, you jump really far.
Honey, I don't know how to switch this on.
You press, hold down here. Yeah.
Hey honey, do you know 98? Maybe 98, 99. I came Jessica. What's her name? Jessica from Maxis. No, Jessica from Maxis. Jessica from Maxis. She was so big that she banged into the wall during the flying fox. So I think you all stay one night cave and one night in the forest.
So this cave's name is Ichibawa, which is Ichi bottom. And whoever named it is really Ichibawa. So, and then Ken said it's someone from MNS. MNS likes to name names like this, naughty names.
This is Gua Gatal actually.
Gua Gatal.
Ah, there's a cave frog. Oh, no, ambil gambar. The toad.
That's the toad.
That toad? Yeah, that's a toad. Max, do you see the
Okay,
toad?
can somebody shine the light for me? Then I can take the picture. Can take with. Turn off your headlamp. Soft light, soft light, soft light. Okay, can. Wow, nice. Okay, no, no, Huawei. Huawei can take.
Toad.
That's blue, is it?
Can you come here?
What? You saw some glow in the dark?
Try to make some light. You saw the frog, right?
Yeah, toad. Uncle can't say toad.
Did you see any bats, Justin?
Yes. Maybe.
Oh, where?
Yeah, we saw one.
And a
Yeah,
bat.
they all fly a lot. Wait.
It's around here.
Get him and me.
Wait, you and Justin go. I'm going to take a picture. Come in.
So dark, how to take?
Yeah, I can. My Huawei can do.
Hey, don't delay the trip. I need to be out of here in 20 minutes. Not like 1.5 hours.
No, I'm just taking picture.
Yeah, every 2 seconds, take one picture.
But usually we make them crawl down here.
Oh, wow. We're not going to do that today.
To have the another experience.
Right. Because sometimes for the research, you guys have to go into very small places. Right.
That's not bad.
This is just somehow the exploration.
Yeah. Stalactites.
I only decide God.
So every time there's like, if there's a stalactite, does that mean there's a crack somewhere where the water is flowing?
Fossil.
There's a bat up here.
What it tells us is that
There's a bat back there.
this was not
It used to be dry
during the
before,
life of the pig.
but now
when it
because of
died,
the rain and
The recent rains.
the
Right.
sediments that got stuck there as well. And all these were like, compressed, is it?
So if it's in Yangon, you have this material to be filled with bones and teeth. It's huge, it's rich, it's so, you have a lot of bones sticking out from the sediment, and the sediment is so hot.
Lengkong.
Yes. Terus tanya aku,
So just now you were telling us about Jurassic period.
Jurassic is nothing to do with now. I'm talking about quaternary. So that's why you really have to know what age you're dealing with, what age context you're looking at.
Orangutan fossil tu dekat mana? Which?
Okay, so orangutan fossil has been found here by one caver, but what we actually published, we didn't manage to get a hold of the orangutan fossil that we found here, but we found in Cistern Cave, in Villa Cave, in Swamp Cave.
Right.
So, 3 caves here in Batu Caves and 1 in Lengkong. So that's in the paper. But now we found it in Marapu, in Wukantan, in Bukit Takun as well.
Could the bones be...
Yeah. Tantan is in Kisar Valley. Yeah, it's some issues going on now because of YTL. YTL got extension of the quarry list.
Could the bones be...
Yeah, it's getting everything.
Could the bones be collected by cave animals that like to gnaw on bones? Or?
Yeah, that can be a possibility.
Right.
But we are not really going into that yet.
Right.
Just work on the identification of the bones and teeth.
Identification
and
first,
at the
yeah.
same time we date.
Right.
So the process, yes, Tekwim is still doing it. You know, Tekwim is looking at marks on bones, maybe porcupine.
Right, right.
You know,
We did
the
hear about the
kind of,
porcupine, yeah.
activities.
Right.
Yeah. But in Lengkong, you will see huge bones, maybe of bobby, maybe of seladang. You know,
Right.
some huge chunk in my room now. So it's kind of a mix of all of the.
How was it? Was it scary?
No, I scratched myself a bit though.
Oh, where? On your knees or your back? Okay, I'll check afterwards, okay? I can see now.
You don't really crawl, is it? Crawl up. Okay.
Yeah.
But you hit your back, is it?
Hey Max, I found some treasure. 50 cents.
This is one of my collaborator, Kira Westerway, that has been dating all the orang-utan material.
Okay, Justin, shine on his back. I want to see.
No, I sure not.
Oh, I can't see. I can't see. Turn around. Turn
Why are
around.
you recording like
Justin, what do you find? Handprints. Oh, wow. Do you think it's prehistoric?
Yeah.
I think it's your hand.
No, it's not.
If it's your hand,
No, wow, it looks old.
See, it's too big for my hand.
It's not my, no, it's, yeah, no, it's too. You see how thin it is for my hand?
Anyway, how can you do it? There's no heat.
Yeah, no, and then if we did it, it will still be freshly wet.
okay, let's tell Dr. Rose and see what.
She probably knows like, oh, that's been here for a while now.
Okay, come. Just
It's happening.
Justin and Max found something.
No, I did
So
not.
I think
He found it.
You found it first.
They found 50 cents.
No, they found a handprint.
Oh.
Yeah, right.
It's a muddy handprint.
No, literally nobody cares.
Oh, lucky helmet. Lucky helmet.
Dr. Rose, I want to ask if any other cave painting Anybody pun tak ada.
Okay, we're heading out of here.
17.
Thank you, Anwar.
18.
Saya susah sikit.
19. 20. 21. Ada juga tak?
Justin, where are you?
Came out, dude.
Huh? Sudah.
Kau dah?
Okay.
No one behind you?
No, I'm the sweeper. Two of them relax down there.
Oh.
The other one, there's no
Oh, there's a wind in here. Nice and cool. Wow, we can camp out here for a while. This makes a nice seat. Hello.
Respect the cave. Max,
See?
okay, Max. Max, no respecting the cave.
See Meng take a selfie.
Narrow passages here. So you can see that
Don't scratch, right? Just now you didn't check properly. Don't
Okay, okay. I'll check again.
It's a lot more dissolution, more aggressive water in terms of acidity to produce this kind of morphology or topography. Okay, so as we move ahead to the next chamber, you will see a lot of blocks on the ground. So besides dissolution of the rock, you will see that some of the rock has been collapsed. So besides dissolution, the cave can also be enlarged by
What's the name of this cave? The Chili Padi. Okay. Okay, thank you.
The water comes from the river.
No. So basically what you have here is actually only rainwater.
Rainwater.
So the rainwater actually weaken the rock by dissolving through the cracks and eventually loosen the blocks and
They collapse. Right.
so you'll see in the next chamber. I believe maybe we are also standing in some blocks. You see? So this cave is large and it has larger. It has spaces for huge.
Max, what is this?
Deposit like that. So this is a huge stalagmite.
Stalagmite?
Yes.
Thanks.
So you can see stalagmites over here and over there as well.
Yeah.
Okay? So we can move on to the next. You can see there has been okay, so there's a hole there. Very nice. That opens to another chamber.
Oh, this is also going to collapse soon.
To another chamber.
Where's the hole?
Dangerous one. It looks like it's going to collapse any moment.
It looks like pieces of rock held together by mud.
Yes. I don't think so. It's a good idea to move around.
So the skylight is up there.
Yeah.
Oh, around the corner. Oh, there's a skylight up there.
To the outside. You can see the tree.
Oh, there is a skylight here.
Yeah, there is another chamber up there as well.
Yeah,
A bigger one.
yeah. It's like an upstairs.
Yeah.
So some areas of the cave, you will see the roof is thick.
Seaman, come.
Shine on the next one.
Come, never mind, we walk. Hey, come, let's walk. Slow.
But it occurred together with Bongo. So because it's orangutan. So because it occurred together with orangutan, we can actually kata apa teka-teka lah. Dia tu tua. Sebab orangutan kita pun 33,000 based on our age, and even the kira punya age pun 27,000. So because it occurs together, our pigs, our porcupine banyak. Dalam 800 lebih dalam satu chamber tu. So I think it's just a process where the water brings in this material together with the
Bukan memang permanent tu.
yeah, bukan permanent situ. But that
So itu
it's
problem.
very important actually site. And
Isn't it
there's another
threatened by some cement or bukan?
area tu okay lagi.
Okay, yeah.
So what have we got here?
Kampung Portuguese.
Who has a right?
When was that?
So what animal is this?
Recently.
A few months ago, when the
This is a dog?
Yeah, it should be dog because the head cannot be so big. Human cannot be so small.
Bones only with the height.
Yeah, it's a dog because you see
Okay,
here
don't touch it.
it's long.
Yeah, you're right.
It doesn't look like a dog.
So they excavated this and then they put it here first, lah. Right? Or is it just lying here?
Can you?
one side and then how you can other parts on the other side.
Yeah.
Oh, wait, auntie, there are beds somewhere around there.
Hey, Max, don't do that because Mama
Domesticated bukan?
Who has a bright light?
You have. Oh no, you for the ceiling, ah?
Yeah, because
I don't have.
hear that squeaking.
Yeah, I don't have.
Beds.
Yeah, we're not supposed to shine at them, no.
you have to stay still because I'm taking picture. Okay, everyone. We should go climbing and hunt bat species that live inside this cave.
There's two
Okay.
types of bats.
in this cave, only one species live roosting here, which is this species, Taphozous melanopogon, or the English name is black-beard tumbat, and the Malay name is kelawar dagu hitam. As you can see here,
black chin.
The chin, the lower area, it have like a black beard. And the interesting is only male individual has this kind of pattern, while female doesn't have it. Okay, and I would like to add more information about food web inside the cave. So bats is very crucial, not just pollinator, seed disperser, insect disperser, but it's bring life inside the cave from its guano.
Right.
Because bats is animal that roosting in the cave but flying outside to find foods, and its guano contains material, fragments of insects, fragments of plants. So all those guano give nutrient source for invertebrate that live inside the cave. For example, the cave cricket, the centipede, and so on. So bat is really important, and bats is also very sensitive. If there is changes of temperature, relative humidity in the cave, it might cause the bats to move to another cave or fly away from the cave. So can you imagine if there is no bats inside the cave, so there is no life, and you can't see all those creatures, and more you can, for example, if we bring public into the cave for tour, so you can show them the live specimen. So I think we come to the end of this session. So before I end this session, I would like to finish it with giving some information about importance of cave and karst conservation, because as you can see, cave and karst, it not just importance for its biodiversity, it's also places where people can gain profit to ecotourism, maintaining the biodiversity, maintaining the ecosystem sustainably, and at the same time earn profit for long time, do some kind of these activities for education, and as well as for adventure activities like rock climbing. Okay. It's also important site for fossils, the paleontology, and archaeological study. And in Malaysia, it's not just Batu Cave. Other places that is made of the limestone cave and karst is the famous one is actually not many people know about it, is the Langkawi Geopark.
Kilim.
Yes, it's actually limestone. So as you can see on the geopark, it's bring benefits to the local people as well if we maintain the ecosystem. Okay, so I think Dr. Rose can also explain a bit about the importance.
So geopark, our first geopark is Langkawi. Langkawi has 3 geosites. They call it geosites. Yeah. So 2 of the 3 is limestone. It's karst, Dan Bunting and Kilim. So our second geopark now coming is Kinta Valley. Kinta Valley is all limestone. So the third, they came together actually. Jerai. Jerai is not karst. And Marapo is also in the list now to be developed into a geopark. So all these 3 except for Jorai, are karst. So it's actually
Jorai is what, the
people
dolomite?
don't really realize it. They are actually karst. So why these places are developed? Because of the importance in terms of geology, in terms of paleontology, biodiversity. So that's what I've been emphasizing. Maybe you don't know about karst. Maybe it's the first time you heard about karst, but it's actually rather important. And Nagamas, maybe our next activity. I really hope to bring you to Nagamas, where we the outstanding complete tiger fossil, embedded in a cave wall.
Where is Nagamas?
It's very rare.
Where?
In Perak, in Perak.
Okay.
So it's part of the Kinta Valley Geopark.
Okay.
Simeng, are you saying something just now?
Yeah, forgot. Sorry, Jorai is dolomite. No.
Jorai is mix of
Quartz,
a lot
quartz.
of number of rocks. The important one is granite. because of the
Okay,
Gunung.
Jorai is
And they
granite.
have, I think it's quartzite, very nice quartzite formation over
Okay,
there. It came together with, developed together with Kinta Valley.
How come it's just by itself? I understand limestone they can be weathered down, so leaving just one. But Jorai, how it managed to be just there by itself?
Jorai is granite.
Granite,
Yeah, granite.
so it's weathered down.
Okay, so it's weathered. Granite is mostly silica, which is 7th in the hardness scale. So it's developed differently compared to limestone. It's actually the material that is hard, which is mostly quartz. Okay, and then of course the formation of the hill also related to the structure as well. So some area is more resistant than the other.
And it's chemically resistant as well?
Chemically resistant.
Right.
Yeah. Because it's mostly silica.
Right. Okay.
It's a bit different. The process is different. Over there, if the granite is weathered, it's disintegrate. All those weak materials, such as feldspar, may turn into clay, and it's just like disintegrated. And the quartz becomes sand.
Right.
But
It
over
turns
here,
to dust.
when it came into contact with water, it's just flow into cracks and joints, and it actually
Become
enlarge.
itself again. Yeah.
Enlarge, and at the same time maybe collapse like this.
Right.
Okay. Collapse due to intersection of, for example, a few cracks. So this crack and this crack, it may
they meet up.
Up and can actually loosen the block and.
Okay.
So it's happened everywhere, even in Kinta Valley. In Batu Cave, those collapse of the cave wall, I don't really see it. I mean the evidence. If in Kinta Valley you see just recent block, recent collapse.
Okay.
Just happened. A few years ago you can see. Last time I was here, it's not there yet. So now it's. And Kacang Putih, Kampung Kacang Putih. Remember the big story about that in 1971? 41 people died under the block.
Yeah, it's near
Kinta.
Gopeng.
No, it's further up, Chero. They have a monument there.
Oh, okay.
So they have squatters living just at the foothill.
Kampung.
Yeah, at the foothill, and then at the foothill they have something like a notch. So a hypothesis say that you have notch at the bottom, and as the water seep through the cracks, it actually intersect with the notch. It becomes weakened, and
the ground gave way.
The block.
Oh, the block fell onto
the block fell. Buried 41 people. They were actually preparing for the Pawali.
Oh no.
So and then they just buried there. They
cannot take them out.
They never removed it. So if you go to the site, you will see a signage telling the story. So this is one of the big events lah. Walaupun it happened in 1971, to tell you the natural process of the.
Have you been to the caves in Krabi? There are also a lot of casts in Krabi.
Yes, I know, but I've Hari itu gimana Kak? Aunang ni.
Ao Nang.
I went to Aunang.
Yeah.
But not to Krang.
Yeah. Ao Nang is
Near there. Yeah, I
Yeah.
went there.
Ao Nang also has a lot of
Mentioned Thailand yet, but it's actually extension of Seto Formation mostly. So
Yeah.
from Langkawi up to north is the same type of rock.
right. Ao Nang looks some places look like Ipoh, got like rocks
Yes,
coming out of the ground. Yeah.
So Seto Formation is definitely the same formation, but the rest I'm not very sure.
Yeah.
So
I forgot my geology already.
any chance his site will collapse
Max.
and the houses so near here, so near the foothill?
Kat mana?
Lembah Damai.
Yes. To me, yes. I don't want to talk about it. Actually,
But there is a
GMT actually came up with a guideline already that you shouldn't build anything 3 times. 3 times the height.
Oh, right.
This is the height. So you should have like 3 times the height of the hill.
Right.
You
The
shouldn't-
distance.
you shouldn't, yeah.
The distance should be
Depends,
3
it depends
times
on the-
further.
Jalan GP there is only 2 times.
Yeah. So it depends also, yes. It depends on the behavior,
Of
the
the rock.
characteristic of the cliff.
Maybe
So
it will
cliff is
collapse
like
the
this.
other side.
Oh, okay.
Cliff is like this, some cliff is
Not so
betul-betul
tall.
tegak.
Yeah.
So some cliff is like this. And then sometimes the cliff has stalactite.
Yeah.
All this are taken into consideration. But I'm taking the maximum lah. So it's 3 times,
Right. If it's stalactites, is it like a sign that there could be a lot of cracks?
It could be because the water, the nice
coming from somewhere.
ornamental feature that you see is actually from water.
Yeah.
And the water actually seeps through cracks.
Right.
Yeah.
Right.
But how strong it is, not my field actually. I'm not an engineering geologist.
And then maybe not in our lifetime.
Maybe not in our lifetime. But as you know, dark cave collapse happens everywhere.
Okay.
It's
So
happening in dark cave actually.
right. So we don't have
It's happening.
to deal with earthquakes or tsunami, but we have to worry about
Yes,
this.
but just after the tsunami, only like minutes after the tsunami, sinkholes occurred in Kinta-Valley. 140 something sinkholes, big and small.
Right.
And it's really is memang kena the time with the
Right.
So
It's
I
affected
think
by
something happened there, but some tremor, underground tremor actually.
The tremors can shake up some more. Holes.
So yeah, it's actually related, and you have already weakened ground. So it's just that a matter of some shaking somewhere.
Yeah.
Actually, kind of trigger the movement.
Makes sense.
So that's about it. I'm not an engineering geologist, I cannot talk much, but I'm doing some work in Kinta-Valley. We actually map the subsurface karst. We map the subsurface sinkhole using a geophysics technique.
Right.
We are doing it a little bit.
Okay.
Can we move to photo session? Maybe
Yes. Thank you.
at the entrance, so the
Okay.
guide is there.
Okay. Yay.
Mana sini?
Guys, let's go for
Okay, guys, we go outside and take a photo.
photo session now. Careful.
Here.
Oh my god. So slippery. Okay, Mexico.
Boys, girls, come, let's go.
Come.
I think I already saw. Where? I don't know. It looks like a cat.
What's that? What do you say?
What are those? Like who's?
Oh, they say it's a dog. They excavated the bones from around here, so they collected all in one pile there. Dean and Max, what you want to show me? Is it very stinky? I don't want to. Oh gosh.
It looks like a cat monkey cross.
How far is it?
Sarah's there.
Oh,
Oops. Wait, just leave it.
where your helmet?
I need to see it.
Huh? Climb in to see it. I don't want to climb in.
No, then you step in. No, you have to step up.
Uh-huh.
And then you can see the black color thing there.
There's another one here.
It's just flattened.
There's one more here.
Do you see the cards?
They're not both.
Oh, nice.
Where?
Can't even see what it is.
Oh,
It stinks.
it's been eaten already.
It's a bat.
Don't touch it.
Hey, stop.
This one was there.
It's a bat. You see the tail?
Make sure you wash your hands. Thanks. What animal do you think it was?
A bat.
A
It
bat?
has a tail.
Okay.
Is that place the corpse place?
Dekat pohon mana? Mana? Puyuh ke kat mana?
Apa yang sangkut?
Kenapa? Kat puyuh ke tenggelam
Ke
ni?
mana yang ada white water jeram? Maybe kena rimba pak lah. Maybe.
Pelan, no bagi okay?
Okay.
Okay.
Thank you so much. Thank you. Yeah, I'll send you some pictures.
Thank you so much.
Thank you. Thank you.
You guys want photos with the hills?
So we were in Lembah Damai. Cili Padi Cave is in Lembah Damai.
Oh, he's taking me cousin.
Yeah, he's taking this.
So that's the end of our walk in the caves today. Really learned a lot from Dr. Rose, Dr. Atika and Dr. Rosli. Really interesting. Still having to go home and process all the information and edit this video for you guys. Anyway, that's all we've got. Peace out.